All right, class. Today we're going to discuss determinants. So, what is a determinant? Determinants determine what's known as an eigenvalue of a number. Big words, Mr. Studer. Come on, knock that stuff off. The best example that I can use for a determinant is that they're used in waves. If you've ever taken a rope and you kind of like spin it so that you have these nodes that happen here. So if I were to flip a rope back and forth, kind of shake it, here, I can do it with this rope here. I kind of create little nodes, and it determines when those nodes occur as to how fast or okay, Mr. Studer. So how does that matter to me? Well, there's two instances in real life where you actually see math using a determinant to calculate certain things uh, that you actually see. So if you're driving your car, most of you guys have practiced driving. If you don't already have your license, if you're not actually driving, when you stop at a stop sign and you feel that jerk back, so as you pull up to the stop sign and you hit stop and you jerk for just a second, we can calculate when that jerk occurs using determinants. Another one is the frequency of your microwave. So I use the power level of my microwave all the time. Um, I make chocolate covered strawberries for my wife. And if you heat up chocolate at max power in a microwave, you will burn it. It doesn't work. So you have to drop the power level down to like 80% or 70%. Some people even say 60% if you want to heat that chocolate up so that it just becomes like a soup and doesn't get burnt. And then you can dip uh, pretzels in or you can dip strawberries in and it works. Well, matrices are used in microwaves to determine the frequency that the microwave is being emitted to have a different power level. So if you're lowering the power level on your microwave, the microwave is doing determinants on matrices of those frequencies in order to lower the power level and not burn your chocolate or your Krause's pizza or whatever it is you got in the mic. There are other examples. Anything dealing with a natural frequency uses determinants to determine the next natural frequency in line. So those are two great examples: is microwaves and uh, stopping your car. Another one might be a radio frequency. It's used in those. It's also used in finding your cell phone. So cell phone towers use matrices and determinants all the time to figure out to determine where you are in the world using GPS tracking and all that. So a lot to do about determinants that don't really apply to you guys until you go on to bigger, better things and you actually start working with it. However, the state of Ohio wants you to learn how a determinant works. We'll start with a 2x2 matrix. It's actually very, very easy. What we're going to do is we're going to start in this top corner and we're going to travel across the diagonal to the bottom corner. And what are we going to do with those numbers? Well, we're going to multiply them together. So we take the first corner and multiply it to the bottom corner, 1 times 4. And then we're going to subtract whatever we go in the other direction. Now, this is important to know because if we go from right to left, that's usually reading, that's a positive thing. And if we go if we go left to right, that's normally how you read is left to right. That's a positive thing. But if we go from right to left, we start on the right side and move over to the left side for you guys who aren't right left savvy. That would be a negative thing. We're traveling backwards. And so we subtract what we multiply when we go backwards. Okay. Well, let's try a problem here now. So if you want to minute mark this, you can say, okay, well, I'm going to rewind it to this minute mark and hear what Studer has to say. So I have this 2x2 matrix. I have 6 and 3 is on the diagonal. So I'm going to do 6 times 3. And I went forward with that, right? So I traveled from left to right. That's a positive move. Now what I'm going to do is I'm going to take the other corner, 5, and multiply it to the other corner, 8. So 5 times 8. However, we went backwards with that one, right? We went from the right to the left, and so that's going to be a negative. So we're going to subtract that. Now, that doesn't seem like much now, but when we do 3x3 and 4x4 matrices to find the determinants, it'll be important that we know traveling left to right is positive and right to left is negative. So we have 6 times 3, which is 18, and 5 times 8, which is 40. And when we subtract the 2, we end up with a negative 22. And that is the answer. That's all we're doing. For a 2 by 2, it's pretty simple. Let's go ahead and take a look at this one. We're going to do 1/3 times 3. So 1/3 times 3. Again, we travel in a positive direction, so that's going to stay positive. Then we do 2 times -6. That travels in a negative direction from right to left. So we're going to subtract 2/3 times -6. Better 3. All right, so let's go ahead and do the math. If I have a 3 on top and a 3 on the bottom, those cancel out, and I just have the number 1. 3 goes into -6, -2 times. So I'm really doing -2 times -2, which is a +4. 1 plus 4 is the number 5, and that would be the answer to that problem. So these are determinants. You will get a question just like that on your quiz, on your quick poll. It happens pretty quick. What I am going to let you know when you're typing these into the quiz, the way I want you to do it, I will give you a row 1. Oh, let's scoot it up just a little bit. Well, what I'll probably do is give you row 1, row 2, and row 3. And so for your answer for row 1, oh no, you don't have to do that. Never mind. I'm talking about multiplying matrices. Completely forget what I just said. I need to go back and do a video on multiplying matrices right quick on how to enter your answers in. That was row 1, row 2. No, your answer is just going to be -22. Done. Your answer is just going to be 5. Done. You don't have to show any work or anything like that. It's just a number. It happens quick. I'm going to hit pause on this. Go ahead and actually, you guys hit pause. It's a digital world. I don't have to wait, but I'm going to wait for just a second for you to hit pause and do these 3 problems on your own to see if you can do them on a piece of paper. Try it. All right, I'll assume you did them. Now I'm going to do the work. So we're going to take the 0.2 times 5, and 0.2 times 5 is going to be the number 1. Then we're going to do 30 times -0.3, which is going to be a -9, I believe. So when we go backwards, we'll subtract that. Now, I just did that in my head. Let's see. Yeah, I'm pretty sure I'm right. Let's go ahead and try it. We'll grab our handy dandy calculator. And just in my head, 30 times 0.3 gives us 9. I was right. It is a 30 times a -0.3, so it'll be a -9. So in this case, what we're going to do is subtract, because we're going backwards, a -9. Whenever you subtract a negative, you're really adding a positive, so this will be 1 plus 9, which is 10, and your answer is 10. So 0.2 times 5 is 1. 30 times 0.3 is 9. Since it's 30 times a negative, it is a -9, and because it's going backwards, we're subtracting a -9. 1 plus 9 is 9. Let's go ahead and take a look at the next one. 1/3 times 3/4. 1/3 times 3/4. And then we're going to do 3 times 5/6. And we're going to subtract that because that is headed backwards. So 3 times 5/6. I have a 3 on top and technically a 3 on the bottom. So when I cancel that out, this 6 and this 3 cancel and it gives me a 2 on the bottom. When I cancel this 3 and this 3, I really have 1/4 minus 5/2. In order to subtract fractions, you need the bottoms the same. So I'm going to multiply these by 2. This gives me 1/4 minus 10/4, and 1 minus 10 is going to be a -9/4. So -9/4 is the answer there. Fractions, ooh, they're tricky. Watch out. So we're going to do 1/2 times 2 pi. And then we're going to subtract 1/8 times the number 4. We'll cancel some fun out here. There's a 2 on top and a 2 on the bottom. 1 times pi is just pi. There's a 4 on top and a 4 on the bottom, which whittles down to a 2, and we're going to subtract 1/2. Now, pi minus 1/2 is a decimal. I want the exact number, and so this is a correct answer right there. Pi minus 1/2 would be your answer. What I'm going to let you know is, on your quiz, I highly doubt that I'm going to give you fractions like this. I highly doubt that I'm going to give you pi. The math is just really easy. So the book is giving you different kinds of problems to work with, like pi minus 1/2, things of that nature. And so our answer here is 10. Our answer here is -9/4, and our answer here is pi minus 1/2. I won't give you problems that difficult on the quiz. I'm going to let you know right now. I may give you decimals like this, but I'm not going to give you a bunch of fractions like this, and I definitely won't give you pi symbols and characters that are irrational, that kind of thing. It'll just be simple numbers. All right, so that's it for this video. We do have a couple other determinant problems that we're going to work on together. If you have questions, please hit me up in the doobly-doo. Send me a comment in the Google comments, private or public, and you can send me emails. I'm also available on the Google Meet. I'm actually meeting right now, but nobody's here. We'll go from there. All right, you crazy cats have a good one. I'm going to shut this down. See ya.